Hello students, today we are going to study uniform circular motion, last part of this lesson. The motion of particle along circumference of a circle with a constant speed is called uniform circular motion. When a body moves with a constant speed on a circular path, it is said to have uniform circular motion. Now let us try to understand with the help of figure. Here we have taken a circular path. P is a present on it. O is a center. Here you can observe we have drawn OP line, that is we are knowing it is position vector, that is known as R. Here the P moves to the P dash. Here we are drawing OP dash, the R dash. We have considered it is OP dash. Now let us try to understand about omega. Omega is known as angular velocity. Here if we will see, the particle P moves on a circle of radius vector r with a uniform angular velocity omega. But if you will see, it's a linear velocity. It is represented by the symbol v. Linear velocity is a v and is a constant in magnitude, but if you will see its direction, it is changes continuously. Here we have to see the particle is moves from p to p dash in a time delta t. Delta t means what? Change in time, that is final time minus initial time. Here if you will see, omega is known as angular velocity, and angular velocity is nothing but rate of change of angular displacement. Here we will observe in figure about delta theta. Delta theta is known as angular displacement. Here delta r also we have taken. The delta r is known as linear displacement, and delta s is known as linear distance. Here the particle is moving from p to p dash. At that time the angular velocity, it is omega, and linear velocity we have seen already. The linear velocity v is a constant in magnitude, but it changes in a direction continuously. Try to understand the formula of angular velocity. Here the definition is, the angular velocity is rate of change of angular displacement, that is omega is equals to limit delta t tends to 0 delta theta upon delta t, where delta theta is angular displacement and delta t is what? Time, change in time, that is final minus initial time. So we have taken omega, the formula of omega, limit delta t tends to 0 delta theta upon delta t. Now let us try to understand relation between linear velocity and angular velocity. As you know already, the symbols of each, linear velocity we are representing by the v, and angular velocity we are representing by the omega. Here the linear velocity is a rate of change of linear displacement, and its formula is v is equals to limit delta t tends to 0 delta s upon delta t, where delta s is what? Linear distance. Linear distance, it is delta s, and delta t, it is change in time, final time minus initial time. Here we have to just put, instead of delta s, r delta theta. If we will put, we will get the equation, that is limit delta t tends to 0 r delta theta upon delta t. We can take r outside, then we will get this equation, v is equals to r into limit delta t tends to 0 delta theta upon delta t. And now only we have seen the formula of omega. Omega is nothing but what? Limit delta t tends to 0 delta theta upon delta t, that is the rate of change of angular displacement. So instead of that we can put omega, and we will get v is equals to r into omega. We can write it is in terms of vector product, that is cross product, v is equals to omega cross r. So this is the relation between linear velocity and angular velocity. Thank you.